Okay, so how would we do that with the software? We have a couple of variables that we need to be concerned with. So let me zoom in here. When the robot's driving down the line, we'll say that the ideal motor speed is 20. And when it's half over the white and half over the black, we'll say that the ideal light reading, or the light reading, is 30. Now if we veer a little bit off to the right, we get over too much white, then this number will increase because more light is reflected into the sensor. And if the robot veers a little bit off to the left, then this number will decrease because less light is reflected back into the sensor. And then we're always checking what is the current light level. And so I left it as a question mark because that's a variable that will always be changing as the robot's driving forward. And then there's this one called the difference, and we'll get into that later. So what would we do here? Well, the first thing, if you watched the other video, the first thing that we'll do is we need to check the sensor, the color sensor, and we need to look at, and I keep talking about light reflecting back into the sensor. The color sensor, or the light sensor, has 3 modes of operation, and what we're doing is measuring how much light is bouncing back up into it, how much is reflected back into it. So we're going to use the RLI, or the reflected light intensity mode of the sensor. And so we're going to say, is it greater than, if you hover over these, they tell you what the what your comparison is. So we're going to do greater than. Is it greater than the ideal, which for in this example is 30? So if the light sensor is greater than 30, then it comes up here and it runs this path. And there's nothing in it yet, but we're going to put something in there. And that you can see because that's a check mark. That means good or okay or correct. And it says, is it greater than 30? If it's not, you see this X, then it comes down here and it runs this path. And there's nothing there yet, but you will put something in there. So let's say that we check the color sensor value. It's a little bit higher than 30. So we veered off to the right a little bit. There's too much light bouncing back into the sensor. So what we need to do is come here to our sensors, get our light sensor, get the current value of it. We need to measure the RLI, and we need to subtract. We need to put a little bit less power to the left motor, because if it's reading more than 30, then we've drifted off a little bit to the right over the white. So we need to put more power to the right motor and less to the left motor, so that we can correct our heading, correct our angle, and come back to the center. So we'll get our math block from the data operations, and we get the, let's see, first we're going to subtract for the left motor, and our ideal, what did we say, it was 30. Actually, put 30 here, and then whatever we're reading, so maybe it's 33 or something, we're going to do 33 take away 30. So the result, which comes out here, would be 3. So we need to get another math block. And we're going to add that value to our, wait a minute, I'm sorry, we're going to subtract that value from our motor speed, from our ideal motor speed, which is 20. And so we'll do 20 take away whatever that difference is. We said 3. So 20 take away 3 would be 17. And we would be putting that into the left motor, which is usually on port B by default. Okay, so this is the premise of the line following. So let's step through this one more time. So first thing we do is we check the light sensor. Is it greater than our ideal light level, which is half on white and half on black? And let's say that it is. In fact, let me get a little text block here. Let's put the values of our demo here, or of our test. Okay, so let's say that the current light level is 33. So say 33, we read 33 out of the light sensor. So instead of 30, we actually start at the beginning. Is it more than 30? Well, yeah, 33 is more than 30, so we come up to this path. Okay, so we need to get whatever value it is. So we read the light sensor value, it's 33. We do a math, so 33 take away 30, or 33 minus 30 equals 3. So we put that into the next math block. 20 minus 3 is 17. So instead of putting a number of how much power we want to put into this motor, the left motor, we just drag the result over. So that's how much power goes to the left motor, and then we do the same thing for the right motor. So we'll copy and paste, and we'll drop these there right after that. And this will be for the right motor. So the right motor is on port C, left motor is on port B. And this time we're going to put that value into this block. So we said it was 33. This time though, so 33 take away 30, because 30 is our ideal value. 33 take away 30 equals 3. And this time we need to add that difference to the right motor. So 20 plus 3 equals 23. And we plug that into the right motor, the motor on port C. So we're putting less power to the left motor and more power to the right motor to change the heading of the robot, and that scoots us back over towards the center. Now what I would like for you guys to do is fill out the bottom part, which is going to be very similar to this, except for you need to put more power to the left motor and less power to the right motor. So just as a hint, I would come here and Control C, Control V, because even when you're coming down here, first thing you got to do is check what is the value of the light sensor, and you need to put that somewhere. You need to add some more blocks here. So that's it for this time. Let me know if you have any comments or questions, and we will see you at our next meeting. Thanks.